So a lot of the times in your graphs, one of the main places that they're going to slow down is your API call, right? So look at this graph, for example, where I am taking my Star Wars cards collection and getting the value for each card through this API so that I can aggregate and figure out how much my cards are worth, right? Well, I'm running 4,000 cards one at a time through this HTTP connector. All right, so finally finished. I can see I've got my values of my different card collection, but it took 12 minutes and 36 seconds to run that. So we can do this way faster. We're going to use two components, the parallel partition, which we're going to stick before our HTTP connector, and the parallel simple gather, which we'll post after our HTTP connector. So you can see these little forks coming out on both sides. And what that means is whatever is happening in between these two is going to happen multiple times in parallel. So instead of just running once and then moving on to the next, running once, moving on to the next, it's going to run 5 or 10 or 100, whatever you set for the allocation, all at once. Okay, so it's going to speed things up considerably. So the first time, this was confusing for me. The first time I was using parallel partition, I was searching for some kind of property in the parallel partition, but it's actually set in the components that are in between our parallel components. In this case, our HTTP connector. You're going to go to the HTTP connector, right click it, and hit set allocation. And then here you can partition by the allocations based on the sandbox, or the simplest is number of workers. And I'm going to set this for 10 workers, okay? So the way that works is instead of calling the API 4,000 times, one after the other, it's going to split it up into 10 groups of 400 and call those 10 groups simultaneously in parallel. So it's going to speed things up considerably. So we can see it says starting parallel worker on node 01, and then how many 1 of 10, 10 of 10, etc. And now all workers are ready and it's processing. And we can see it's already moving way quicker than it was before. So you'll notice on the edge where we normally only have one number with all the records, we've actually got 10 different numbers right now with a percentage there. That's showing us how much of the data is being handled by each worker. Since we didn't set any kind of partition key in our parallel partition, we just sent all the data equally to all the different edges, and so they're all at 10%. And if we'd put some kind of key in the parallel partition, then we could see what percentage of the data each key is representing, and it would show us that way. And so we'd see that finished in 2 minutes and 54 seconds instead of in 12 minutes, right? Saved ourselves 10 minutes just by running that in parallel. To know how many partitions are best, you're just going to have to toy around and see what works best in your environment. With my little speed test, I could see that I got my best success with 10 partitions and no real improvement after that. With previous runs, I could even see it slowing down with the 100 partitions because I was overwhelming my system. So just toy around and find what works best for your environment. And if you want to learn more about parallel processing and all the different things you can do with it, you can head on over to the CloverDX Academy and book a course on parallel processing.